Welcome to the Trend Detection Podcast, powered by Siemens.
Hello and welcome to Trend Detection. We are back with Johnathan Bonner for another episode of our mini-series, Predictive Maintenance Unmasked. In this series, we're going to be covering a different vertical each episode and how predictive maintenance helps navigate the industrial challenges that arise in each one. So in this episode, we will be discussing navigating the challenges that arise in heavy industry. So hi Johnathan, thank you for joining us again. How are you today?
Very well, thanks. How are you?
Yeah, all good, thank you. It's really nice to have you back for another episode. So I guess let's dive straight in with the questions. So it'd be really great if you could start off just telling me about Senseye Predictive Maintenance experience within heavy industry.
Yeah, well, if you look at heavy industry, it's typically categorized as the manufacture of large or heavy items, or the processing of materials in bulk. So Senseye's experience in this industry vertical area really is around pulp and paper manufacturing, as well as processing materials such as concrete, glass, sugar, chemicals, and I would even say container handling. So quite an extensive experience over the years.
Oh, no, thank you for that. That's a really helpful overview and a really insightful aspect on that. So thank you for providing that information. So it'd be good to touch on how important is asset reliability in heavy industry. So if you could shed a little bit of light on that, that'd be really helpful.
Yeah. Well, when you think about assets in heavy industry, you have to think big. Huge assets, sometimes 3, 4, 5 stories tall, hundreds of meters long, thousands of very big components and moving parts. So reliability is extremely important from multiple factors. First, if assets fail, they can be hard to get to. They can take specialist equipment to try and manipulate to get to those components. It takes teams of people, huge amounts of planning, all of which add time onto the repair. So you are now no longer producing, processing, moving material like you should be. So reliability as a whole is absolutely crucial. Also, within heavy industry, the environments can be quite dangerous. So when you're sending off a maintenance or a production team to go and investigate, to go and do repair or work on these assets, these areas, it can be quite dangerous.
Yeah.
So if you have higher reliability, you have less potential for unsafe actions or unsafe events to occur.
Of course, yeah, and obviously you've touched on the sense of the consequences if an asset does fail. But it'd be really great to hear more about kind of what are the costs associated with these incidents of unplanned downtime and kind of the impact of the consequences that occur from that.
Yeah, well, I guess it all depends on what is being made effectively. But typically, when we look at the cost of unplanned downtime, we are looking at the tens or hundreds of thousands of pounds, dollars, euros per hour. So extremely high costs associated with not producing, not making. But when we look at the cost of components, the cost of these parts, when you're doing maintenance, we are also looking at high numbers. Even just your planned maintenance activity in heavy industry, the numbers around or associated with your planned maintenance costs is huge. If you think about replacing these massive bearings or maybe a bent drive shaft or even just a roller, let's say, we're looking at, again, tens to hundreds of thousands of pounds for these components to just be replaced. And again, because it takes time, you're adding on additional cost for your teams, potential overtime costs. There's costs associated with idling. And yeah, it is an extremely costly thing if you're not producing when in heavy industry.
Of course, yeah, no, I imagine that's extremely concerning kind of point for customers in that industry, and it's a pressing kind of subject on how they can prevent these issues from happening. So just moving on, and this actually ties quite nicely to our next question. How would you say that predictive maintenance improves the lifespan and efficiency of machinery in heavy industry?
Well, for those who are a little bit unsure, predictive maintenance really is an evolution from traditional condition monitoring. It just automates the process of data collection, data analysis, and reporting. And really, the main function of a good predictive maintenance solution is to give early indication of asset degradation. Now, when someone in maintenance, the maintenance team have this indication of early asset degradation, they can do something small now to avoid a negative outcome later, a much bigger, much more costly negative outcome. And in most cases, you can extend the lifespan. So my example that I typically give is it's much easier to grease a bearing now than it is to replace a bearing later on.
Yeah.
So when we are monitoring assets, I guess in all industries, if you have early indication that something small is changing, you can do something like grease a bearing. And by greasing that bearing, you not only extend the lifespan of that bearing, but you avoid secondary or consequential damage should that bearing fail, such as bending your drive shafts, inducing imbalance, misalignments, messing around with your couplings, for example. So if everything is running well, you're able to keep all the components in a reliable state. The lifespan of an asset, of a machine, of a production line is really, there's no limit to it. So really, it's about having early indications so you can do something small now.
Exactly, yeah. No, I think that's again such insightful information regarding the lifespan and efficiency, and I think that again links really nicely onto our next question. Kind of focusing on the data aspect of a PDM deployment. So it'd be really interesting if you could share some of your expertise on how can heavy industry companies effectively collect and analyze data for predictive maintenance.
Yeah, I would say typically with heavy industry, the level of automation is quite high. And that is good for predictive maintenance because there is data, typically speaking, data available, useful data for predictive maintenance. Now, the data that we would look for in a predictive maintenance project is two forms, mainly. First is condition monitoring data, such as pressure, current, torque, vibration, temperature, speed, flow, cycle time, whatever is relevant to build a baseline understanding of normal behavior, but then to highlight signs of degradation. And a lot of that information is currently available within the automation layer. We also look for operational data, such as speed, variable speed drives. These could be recipe identifiers. In heavy industry, you could be looking at different widths of product coming out the end of the line. And that operational identification or recipe identifier gives the application an understanding of normal operating change. So again, there is data readily available from the automation layer within heavy industry that is useful and can be used in predictive maintenance. This heavily reduces the amount of time and cost associated with installing new hardware, new sensors, and so on. Also, what we find is that this data is already being used, but mainly for process visualization. So there are dashboards and screens and so on that production teams are utilizing. However, when it comes to asset reliability, although the data is available, not much of that is visible. So by being able to collect the data from various sources and OEMs on the automation layer, by being able to get contextual information from process systems, to unify that and to bring that into automated learning and automated diagnostics, automated reporting, that really enables effective and cost-effective predictive maintenance. So whenever we're investigating a client's environment, we help to assess their automation layer, find out where relevant data may be sitting, what relevant data we can pull from it, how do we unify that and collect it and put that into the cloud for analysis. And typically, we have run a number of projects where we didn't have to install any new hardware or systems to collect the data or even push it to the cloud. That was already existing on site. So our time to value was heavily decreased because heavy industry already has the systems infrastructure in place to enable predictive maintenance.
No, that's great. Thank you, Jonathan. That's extremely, insightful and helpful. And I think again, this actually links into our next question. fairly well, and it'd be really kind of good to get your perspective on the topic of necessary skills. So if you can, it'd be great to hear your thoughts on, is there a lack of necessary skills in heavy industry for implementing predictive maintenance, and what areas do you feel in particular, are lacking in those skill sets?
Well, from my experience, there is definitely not a lack of necessary skills. Quite often you'll find in heavy industry, these heavy processing environments, the production teams, the maintenance teams all have to go through a series of tests before getting the job, really proving their competence in the role before they start. Yes, there is also programs where you have apprentices and so on joining and learning from the experienced team. But typically there is a huge wealth of knowledge, of experience, and skills on site readily available. When looking at the type of characters we would look for within a project, the key characters, the key skill sets, we would normally want maintenance leads or maintenance management representation. So this is really because the maintenance teams typically are our end user. These are the teams who will pick up notifications, be able to investigate, and more importantly, action out maintenance when required. So having a lead of maintenance in a project is always very good. We look to establish a PDM champion as well, someone who is really keen on new technology, someone who can give day-to-day progress and drive to a project, especially in the beginning stages. We also look for OT representation, so that's operational technology, like a controls or drives engineer, for example, because they can make data more readily available from the automation layer. And with any project like this, we need IT representation, effectively making data available in the cloud. And from my experience, all of these roles and functions are already there existing on site. I guess one of the biggest challenges is making sure they have time associated or allocated to the project.
Oh, no, that's great. Thank you, Jonathan. It'd be good to hear your thoughts on what actually would you need to qualify as a PDM champion. I know this is kind of a slightly off-topic question, but I think for anyone listening who is interested in getting into that area, like what does a PDM champion consist of, and how would you make those steps to become and achieve, taking on that role?
I guess identifying a PDM champion can be quite hard because they can come in many different forms. Sometimes they're a part of the maintenance team, sometimes they're a part of the production team, sometimes they're a part of the automation, controls and drives team. So where they start off within the business is sort of irrelevant, although they need to be linked with assets, reliability, maintenance, and so on.
Yeah.
But the main characteristic that we look for, as I've said, is someone who is excited about technology, someone who's going to really get stuck into the project, to understand the unique, I guess, complexity of predictive maintenance, of how to implement predictive maintenance, on how to drive it forward, and who's willing to learn, who's really willing to get stuck in and put some effort behind the project. Because without having that time and resource from the sites, from the teams, the project doesn't go anywhere. So we're looking for someone who's enthusiastic. And in some cases, that has come to us in the form of an apprentice, just because they are excited for new technologies and maybe they have a bit more time than the skilled engineers on site, let's say.
I know that's great. Thanks, Jonathan. And I guess that's really kind of sends a hopeful message for, for young people who are hoping to get into this industry, and that there's so much opportunity there. So thank you for sharing that information. I think it really kind of projects the future of predictive maintenance as well, and heavy industry, and it just kind of shows, there's so much to learn and so much in terms of job roles. There's so many skills you can learn and you can grow. So that's a really exciting aspect. So thank you for sharing that. So just moving on to a different topic, it'd be really interesting to hear a little bit more about heavy industry companies and their kind of day to day and their approach with adopting predictive maintenance. So as I assume resistance can be a factor when adopting a new technology into a well-established business. So it'd be really great if you could shed a little bit of insight onto, how do heavy industry companies overcome that initial resistance when adopting predictive maintenance?
Well, that resistance can come from multiple levels. Quite often it can come from a management level or a board decision-making level, mainly because their main focus is to keep production going, to keep making money effectively, and they want to know that anything they invest in is going to show a return of investment. So to win that level over, we really do try and convey the benefits of predictive maintenance, but we can't just speak about it generically. We have to make it personalized to their environment, to their specific use case. So one of the very first things that we do is we target the value. We help to identify areas, assets, lines that have the highest maintenance activity, and we project a reduction in that maintenance activity through a 12-month period. From there, we can associate a financial benefit to it, but we also then target which assets, areas, lines are going to give us the highest value in running the project. So that is what we start assessing from there. And when you're looking at resistance from the shop floor level, that can come because there may be thoughts on this new technology is going to replace me, going to take away my job. This is going to add on more time, more work, more tasks to do in a day. And the way that we address that really is around educating the shop floor staff on what predictive maintenance is about, making sure that they feel comfortable on what it is we're trying to achieve, that we're not there to take away their jobs, but rather make them more efficient, make them the heroes of the company because they've achieved huge reliability standards, massive reductions in unplanned downtime, far more efficient planned maintenance activities, a reduction in spares usage. So they actually become the heroes of the company rather than a target, let's say. And then as far as what the solution needs to be and do for the organization, is more importantly, you can't have something that is going to become another huge task for all the teams to monitor and track and implement. So it needs to be easy to use. It also cannot be over alerting users because then they start to lose confidence within the system. So whatever the output is of your predictive maintenance solution, it needs to be easy to use and the alerts and notifications need to be relevant. So we go through a huge evaluation process. I say huge, it's an in-depth evaluation process to best identify the assets, the operational complexity, the data that's required, so that the output of the solution is relevant for them. And they embrace it because they have confidence and trust in the system.
That's great, thank you, Jonathan. So you touched on the topic of financial benefit for companies, which obviously is the main concern for most companies adopting PDM. So it'd be really great to hear your thoughts on how heavy industry companies evaluate the return on investment for predictive maintenance. Like, what are those main kind of KPIs and how are they evaluated?
Well, typically we would look at various maintenance costs, such as reduction in unplanned downtime, reduction in planned maintenance. But when we're calculating reduction in unplanned downtime or breakdown events, there is the production loss for that time spent not producing. There is the labor spent in your reactive breakdown maintenance, or the labor costs associated with the work being done. There is waste costs. So this could be waste materials, waste consumables. This could be waste of electricity because the line is idling. And if you are looking at a bottleneck within the production, that has consequential effect upstream. So whatever the following process that relies on this part of the process to feed, they are also then stuck waiting for production to start or continue at this end. Your planned maintenance, obviously, that is looking at, again, hours spent on planned maintenance. But we also then try and evaluate the impact on spares and inventory, quite often with heavy industry as well. These components, these assets, they're not readily available. You don't have the spares necessarily in stock. Or if you do, you may have one. So if you have to have emergency transportation of spares, that is extremely costly. It could also take ages for these spares to be specially made, customized for your environment, for your specific machine. That takes time. So the impact of a failure, unplanned failure, let's say, can have a huge impact on, I guess, the cost, return of investment. So by having a clear idea of what is costing the most amount of money or what costs are associated with various maintenance activities, we can then help to project value. But there are also intangible impacts, such as your company's credibility when it comes to delivering orders. So if you have a higher rate of reliability, you can always make sure your orders are on time, the product quality is of the highest standard, and yeah, you have a better name for yourselves, let's say.
That's great, thank you, Jonathan. And I guess this touches on kind of our next topic of scalability. So for companies to actually grow, it's important to scale the product as well. So it'd be really interesting to hear your kind of thoughts on how companies can ensure their predictive maintenance is scalable, in long term, and make sure that they're actually reaching their KPI targets.
My response to this is going to be a little bit biased because I am
That's okay.
favorable of the Senseye predictive maintenance approach. But for a predictive maintenance solution to be scalable, it needs to be applicable on all asset types. So if your approach is to customize and specially build machine learning models for specific asset types, specific processes, that takes a huge amount of time. It takes a huge amount of people, it takes a huge amount of data. And quite often, what I've seen so many times in the past is that this now becomes a data science project rather than focusing on asset reliability, or at least using condition monitoring and asset reliability principles within the process of building machine learning models. So our approach is completely different, where all of the machine learning algorithms have been designed, first of all, to build a baseline understanding of normal, then to alert to abnormal, to learn from failure fingerprints, failure modes, to give diagnostic messaging, and then eventually lead time to repair. So the Senseye approach is not to be a specialist in any one asset type, rather that the application is designed to automatically build models specific for that asset. And then be able to scale that out. So really, for the Senseye application, it doesn't matter what asset we onboard, it will automatically learn what is normal, alert for abnormal. And currently, we're monitoring many hundreds of different asset types and tens of thousands of assets globally. So our approach is truly scalable.
Honored. Thank you, Jonathan. Again, that's really interesting, insightful to hear. And I think it's super important for companies to know, this is not a short-term fix, it's for the future. So thank you for providing all that information. And so for our final question, just to wrap up the episode, it'd be really great to hear your personal perspective on how fast-changing technology can impact heavy industry and allow them to ensure that their predictive maintenance stays relevant.
Really, my advice for this is that companies should ensure that their infrastructure, systems, new technologies, new machinery that they are installing or upgrading or whatever it may be, is interoperable with everything else. So often we come across systems or OEM automation layers, for example, that are black box. All the relevant information is there. Let's say the data we need for predictive maintenance, it's there, but we cannot get access to it because it's not an interoperable system. Now, I mentioned earlier about the data we require for predictive maintenance, but that data and similar types of data like that can also be used for OEM calculations, for energy efficiency, and so on. So it's not just around predictive maintenance and being able to evolve that. It's around other initiatives you want to have in the future. This may start with predictive maintenance and move on to energy efficiency and then monitoring of OEE and so on. So if all of your systems are interoperable with each other, if they can all communicate with each other, if you can have access to all of the relevant information, you're very much future-proofing yourself for any initiative to come. And that is also one of the many reasons why I absolutely love being a part of Siemens, is because all of the Siemens technologies and systems are interoperable. So when we are suggesting additional hardware, additional systems to enable predictive maintenance, I know that for a customer's future initiatives, those same systems, bits of hardware will enable those future initiatives. So it is future-proofing yourself for whatever you want to achieve in the future to come.
That's great again. Thank you, Johnathan. So I guess that wraps up our discussion today. Thank you so much for joining us, Johnathan. And thank you, listeners, for tuning in. We'll be back very soon with another episode of Trend Detection. Thank you and goodbye.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.